Welcome to the CAP platform demo. In this demo, we will use some of the elements of a complete CAP platform. In particular, we will use a custom OPC-UA server, the OPC-UA agent, an asset included in the FiWare catalog and powered by engineering. The FiWare Orion Context Broker, the Orion PySpark connector, foreground of the CAPRI project and incubated in the FiWare catalog. FiWare Draco, a MySQL database, and the visualization layer, in this case represented by Grafana. Let's start with Draco. Draco is a tool based on Apache NiFi. It is capable of managing flows of information between Orion Context Broker and a database. By doing so, this tool is able to save historical data on database, since the context broker usually stores only the latest updated value. We already set up our database connection for Draco. This is the OPC-UA server integrating our simulator. It acts as the source of the data flow. This server simulates, with a custom logic, 3 sensors of a drilling machine. Those sensors monitor the temperature, the RPM value and the energy consumption. A 4th attribute indicates the operating mode. Our scope is to use the whole CAP platform to monitor the machine and automatically act when necessary. Let's run the machine. The server is now up and running. Using an external client, it is possible to monitor and control the machine manually. However, after the whole CAP is set up, we will not need it anymore. It is possible to see that the machine is in started mode. RPM value is 3000. Energy consumption value is 3 kWh. Now, let's stop the machine for a while. We can see it cooling down pretty fast. Before starting the machine again, let's introduce the FiWare OPC-UA IoT agent. This tool connects to a running OPC-UA server and maps entities, attributes, and commands from this server to the Orion Context Broker. Now, let's start the agent. Upon starting, the mapping is done and now the agent starts transmitting attribute updates to the Context Broker. The communication is also bidirectional. By calling commands from Orion, the agent is able to execute them on the OPC-UA server. We can start the machine again to see the flow of data through Draco. Through the agent, the context broker is updating. To allow those updates to flow through Draco as well, the entity in Orion must be subscribed to it. Draco is starting to receive some data. There are some data flowing from the HTTP listening module to the log attribute 1. By browsing the tables, it is possible to see those updates in the MySQL database. The historicization data flow is now totally set up. We stopped the machine again to describe the Orion PySpark connector and what it is able to do. This tool provides an endpoint to receive entity notifications. In fact, like Draco, it needs the entity to be subscribed to that endpoint. Once data are received, it pushes them into the PySpark flow using a multi-thread socket server managing multiple connections to the PySpark socket for text streaming. Once in this flow, every algorithm running through PySpark can manipulate those data. Moreover, the connector is able to write back results to the context broker using its reply-side API. This program, for example, implements an algorithm that monitors the values of the machine attributes. When some attribute reaches a certain threshold, the algorithm will notify the context broker, sending a command to modify the machine operating mode. We will see the connector in action later in this demo. The Orion PySpark connector is made of one connector library file and one configuration file. Moreover, it is possible to use the supporting CLI subscription tool that makes subscriptions to the desired entity easier. This is the configuration file to be set before using the connector. It contains some parameters. For example, this is the internal endpoint IP address and port, the socket port, socket buffer. These parameters are for the receiving communication side of the connector, while, for the other side, it is possible to set up a API URL, a API method, FIWare service and service path and other parameters to structure more complex messages. Let's see the connector in action. We already started the machine and now we are starting the PySpark algorithm. Since we used also the subscription tool, it now asks us to select an entity among the ones available in the context broker. Then, it asks us to select the list of attributes we want to receive. We will select energy consumption, mode, RPM, and temperature. Once we have done, we can use the special quick command to proceed. The tool is now asking us to select the attribute that will fire the notification. In our case, we want to be notified on every temperature attribute change only. We can quit the condition attribute selection. In the end, the tool asks us to input a brief description for the notification we are sending. Finally, the subscription is ready. The connector is now starting to receive updates from Orion. It is possible to see that the machine, from started mode, was set by the algorithm into empowering mode, and RPM, energy consumption, and temperature are rising. Since the temperature rose above 400 degrees Celsius and the energy consumption rose above 8 kWh, the machine was set in depowering mode. Now the energy consumption is lowering, however the temperature will still rise since the machine is up. Now the machine reached the critical temperature of 800 degrees Celsius and it was forced to stop by our algorithm. It will cool down to room temperature, then the algorithm will start it again. We also concluded this interactive data flow. Returning back to Draco, meanwhile, we accumulated a quite large amount of historical data. Using the visualization layer of the CAP platform, it is possible to plot and watch those data in well-structured charts. This is the CAP platform visualization layer. The tool we are showing in this demo is Grafana. It allows the creation of dashboards, making them available to specific users or teams. Before creating a dashboard, a data source must be set on Grafana. In our case, we will select MySQL. Then, we have to fill some fields such as the database server host name, the database name, the user and password. In the end, click Save and Test to add it. We imported our data source before. Once our source is ready, we can create a new dashboard. A dashboard is made of multiple panels, each containing one chart. We can select from a large amount of chart types. Once we selected the type, we can start building our query using the Easy Query Builder. If we have to build complex query, it is possible to write SQL queries by hand. We already created some dashboard for our use case. This dashboard contains 3 time series chart monitoring the 3 sensors. Opening one of them, it is possible to see the used and handwritten query. We are querying the same table showed before, plotting real-time data. By viewing at the chart, we can easily understand the temperature behavior. By viewing also the other charts in the dashboard, we can easily understand the whole machine behavior. Moreover, at the top of this dashboard, there is a custom table showing only the last state of our machine. We can also check the interactions between the connector and the dashboards. When the connector updates the machine state to started, right here, it is possible to see the real-time update in the dashboard as soon as it refreshes. That's all for this CAP platform demo. Thanks for watching.